Hello, in this lecture we'll find out the radius of a circle. In the drawing we have a circle. Inside this circle we have chord AC that is equal to square root of 2 units. We have chord DB that is equal to 2 units. And finally we have this angle DEB that is equal to 45 degrees. And our mission is to find out the radius of this circle. Okay, so first of all, in this lecture we use two main rules. We have rule number 1, it states that a peripheral a central angle is twice as big as the peripheral angle resting on the same chord. Here, again, the central angle is twice as big as the peripheral angle resting on the same chord. So here we have peripheral angle AOB equals to 2 times, actually this is the central angle AOB, that is equal to twice, it is twice as big as the peripheral angle, this angle ACB. Why? Because those two angles are resting on the same chord AB. Repeat again. Peripheral angle AOB rests on chord AB. Peripheral angle, the central angle AOB rests on chord AB, and the peripheral angle AOB rests on the same chord AB. Therefore, peripheral angle AOB equals to 2 times the central angle AOB equals to 2 times the peripheral angle AOB. Here, the central angle AOB equals to 2 times the size of the peripheral angle ACB. Okay, and we have also rule number 2 is the law of cosines. In any triangle ABC could be any triangle. The length of side AB equals to 1 unit, side AC equals to B units in its length, and finally side BC equals to 3 units in its length. Then, according to the law of cosines, C square equals to A square plus B square minus 2 times A times B times cosine theta. Okay, and from this equation it is very easy to arrive to this equation that cosine theta equals to A square plus B square minus C square over 2 times A times B. Okay, cosine theta equals to A square plus B square minus C square over 2 times A times B. Okay, so we define the center of this circle as O. This is the center of the circle. In the next step, we join points O and D together by a straight line. Or first of all, points O and B together by a straight line. So actually, here we join points O and D together by a straight line. We join points O and N together by a straight line. And finally, we join points O and C together by a straight line. OB is the radius of this circle, so we define the radius of this circle as capital R, OB is capital R, OD is also capital R, OA equals to capital R, and finally OC is also the radius of the circle that is equal to capital R. Okay. If we focus on the straight line AB, its point E, the sum of the angles must be equal to 180 degrees. If you focus on the upper side of the straight line AB at point E, the sum of the angles must be equal to 180 degrees. So which angles we have here? This angle is 45 degrees. Therefore, the missing angle must be equal to 135 degrees in its size. We will define we have here chord AC, and we have peripheral angle ADC. We define it as y over 2. According to our definition, the size of angle ADC equals to y over 2 angles. Therefore, the central angle AOC, this central angle AOC that rests on the same chord AC, must be equal to twice of it. That is to say, it is y in the next step we'll focus on chord DB. On chord DB we have peripheral angle BAD. This angle BAD, we define it as x over 2. Therefore, the peripheral angle BOD that rests on the same chord BD must be equal to x. Okay. In the next step, we'll focus on triangle AEB. This triangle, the sum of the angles must be equal to 180 degrees. So which angles we have? A triangle AED. We have this angle x over 2 plus this angle y over 2 plus this angle that is 135 degrees in its size. In total, they must be equal to 180 units, 180 degrees. Okay, repeat again. In triangle AED, the sum of the angles must be equal to 180 degrees. So x over 2 plus y over 2 plus 135 degrees must be equal to 180 degrees. So we subtract 135 degrees from this equation, and we get that x over 2 plus y over 2 equals to 180 degrees minus 135 degrees is 45 degrees. We multiply this equation by 2, and we get that x plus y equals to 90 degrees. and x plus y equals to 90 degrees. We subtract x from this equation and we get that y equals to 90 degrees minus x. Okay, and get y equals to 90 degrees minus x inside. In the next step, we will focus on triangle DOB. Triangle DOB, according to the law of cosines, this triangle DOB, according to the law of cosines, cosine x equals to r square plus r square minus 2 times 2. It's actually r square plus r square minus c square, it is db square, that is 2 square. It's actually also 2 times 2 over 2 times r times r. Okay, in the triangle here, according to the law of cosines, we get that cosine x equals to r square plus r square minus 2 square over 2 times r times r. So here, cosine x equals to r square plus r square is 2r square minus 2 square is 4 over 2r times r is 2r square. Okay, so cosine x equals to 2r square over 2r square is 1, and 4 over 2 is 2, so here we have 2 over r square. This is equation number 1. Cosine x equals to 1 minus 2 over r square. In the next step, we will focus on triangle AOC. In this triangle AOC, the great triangle AOC, according to the law of cosines, cosine y equals to r square plus r square, that is 2r square, minus square root of 2 square, that is 2, over 2 times r, that is 2r square. Okay, so in the green triangle ACO, according to the law of cosines, we get that cosine y equals to 2r square minus 2 over 2r square. So cosine y equals to 2r square over 2r square is 1, minus 2 over 2r square is 1 over r square. This is equation number 2. We have already found out that y equals to 90 degrees minus x. Here, this equation, y equals to 90 degrees minus x. So substitute cosine y in this equation number 2 by 90 minus x. So cosine y equals to cosine 90 degrees minus x, and cosine 90 degrees minus x equals to sinus x. Okay, so actually we found out that cosine y equals to sinus x, so we can substitute cosine y in this equation number 2 by sinus x, and we get that according to equation number 2, sinus x equals to 1 minus 1 over r square. This is according to equation number 2, and we have already found out that according to equation number 1, cosine x equals to cosine x equals to 1 minus 2 over r square. Okay, so again, cosine x equals to 1 over 2 over 1 minus 2 over r square. In the next step, we will substitute 1 over r square by t will be equal to t. So according to equation number 1, we have cosine x that is equal to 1 minus 2 over r squared. 1 over r squared is t, so it will be equal to minus 2, and 1 over r squared is t, so it is 1 minus 2t. This is cosine x, and sinus x equals to sinus x equals to 1 minus 1 over r square, but 1 over r square is t, so it is 1 over 1 minus t. In the next step, we'll use the trigonometric identity that states that sinus square theta plus cosine square theta equals to 1. Again, the trigonometric identity that states that sinus square theta plus cosine square theta equals to 1. So according to this trigonometric identity, we get that sinus x equals to 1 over 1 minus t. Therefore, sinus square x will be equal to 1 minus t squared. So we have plus cosine theta equals to 1. So we have cosine x equals to 1 minus 2t. Therefore, cosine square theta will be equal to 1 minus 2t squared, and it is equal to 1. So we found out that according to the trigonometric identity that sinus square theta plus cosine square theta equals to 1, that 1 minus t squared plus 1 minus 2t squared equals to 1. We'll open the bracket on this side of the equation, equation number 1, and we get that 1 minus t squared is 1 squared, that is 1, plus t squared minus 2t plus 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared, that is 4t squared, minus 2 times 2t is minus 4t, equals to 1. Okay, so here we have t squared plus 4t squared is 5t squared, and minus 2t minus 4t is minus 6t, and we have here we'll subtract from this equation 1, so we left only with 1, that is equal to 0. So 5t squared minus 6t plus 1 equals to 0. 5t squared minus 6t is minus 6t is minus 5t minus t plus 1, it is equal to 0. In the next step, we'll take out a common factor of 5t from those two expressions. 5t, so inside the brackets we left with t and minus 1, and we'll take a common factor of minus 1 from those two expressions, so inside the brackets we left with t minus 1, that is equal to 0. The next step we take out t minus 1 as a common factor from those two expressions, so it is t minus 1 is taken out as a common factor, so inside the brackets we have 5 5t minus 1 equals to 0. So t minus 1 times 5t minus 1 equals to 0. So we have two options here. The first option is that either t minus 1 equals to 0 or 5t minus 1 equals to 0. Here t minus 1 equals to 0, so t equals to 1, and t equals to 1 over r squared. So 1 over r squared equals to 1. We multiply this equation by r squared, and we get that r squared equals to 1. We take out, if r squared equals to 1, we take out the square from this equation, and we get that r equals to either plus 1 or r equals to minus 1, because of the fact that r is the length of the radius. It cannot be equal to a negative number, so r equals to minus 1 will get cancelled. We left only if r equals to plus 1. Okay. Here 5t minus 1 equals to 0. Five t equals to 1. So we divide this equation by 5, and we get that t equals to 1 over 5. And t is 1 over r squared equals to 1 over 5. We cross multiply this equation, and we get that r squared equals to 5. We take out the square from this, we take a root from this equation, and we get that r equals to either plus square root of 5 or r equals to minus square root of 5, and because of the fact that r is the left, it cannot be equal to minus square root of 5, so we left only if r equals to square root of 5 units. Okay. So here we have dB called dB chord dB is not the diameter of this circle. Why? Because it doesn't passes through the center of the circle, and therefore it must be shorter than the diameter. Why? Because the diameter of a circle is the longest chord in the circle. Okay? The diameter of the circle is 2 times the radius. So 2 times the radius capital R is greater than dB, because dB is not the diameter, therefore it must be shorter than the diameter. Again, the diameter to R must be longer than chord dB, because the diameter is the longest chord in the circle. Okay, so 2R is greater than dB, and dB equals to 2. So 2R is greater than 2. Here we will divide this inequality by 2, and we get that R is greater than 1. So R is greater than 1, so because of the fact that it's greater than 1, then the possibility that R equals to 1 unit is not correct, because R must be greater than 1. Then we have R, capital R, equals to square root of 5. So we're left only with the second possibility, that the radius of the circle is square root of 5 units. That is actually 2 times 2, 3, 6 units. So we found out that the radius of this circle, capital R, equals to 2 times 2, 3, 6 units, or square root of 5 units in its length. In the next step, I will summarize the lecture. So, in this lecture, we actually found the radius of this circle. We used 2 rules. We have the first rule, that the central angle is twice as big as the peripheral angle resting on the same chord. The peripheral angle AOB rests on chord AB, and actually the central angle AOB rests on chord AB, and the peripheral angle ACB rests on the same chord AB. Therefore, the central angle AOB must be twice as big as the peripheral angle AOB, or angle AOB equals to 2 times angle ACB. Okay? Then use a second rule, that is the law of cosines in any triangle. ABC could be any triangle. side AB equals to units in itself, side AC equals to units in itself, and finally side BC equals to units in itself. And this angle is angle theta. Therefore, in this triangle ABC, according to the law of cosines, C square equals to A square plus B square minus 2 times AB cosine theta. In this equation, it is very easy to arrive to this equation that cosine theta equals to A square plus B square minus C square over 2 times A times B. Again, cosine theta equals to A square plus B square minus C square over 2 times A times B. So first of all, from point O is the center of the circle. From point O, we join points O and B together by straight line. We join points O and C, points O and D, and points O and A. So all those line segments are the radius of this circle, and the radius of this circle is equal to capital R. So all the four line segments OB, OD, OA, and OC equals to capital R. And in the next step, we focus on chord AC. We define this angle, the peripheral angle ADC rests on chord AC. We define it as y over 2. Therefore, the central angle AOC that rests on the same chord AC, must be equal twice of this angle, that is y over 2. Y over 2 times 2 is y. So the central angle AOC equals to y. Then we focused on chord DB. On chord DB, we have this angle, the peripheral angle BAD rests on chord BD, and we define this peripheral angle BAD as x over 2. Therefore, the central angle BOD that rests on the same chord BD, must be equal to twice of this angle, that is x over 2. Therefore, it must be equal to x. Okay? So, here we focused on the straight line AB. On the straight line AB, we have this angle equals to 45 degrees. AB is a straight line, and we have the whole the sum of the angles on one side of the straight line is equal to 180 degrees. So if we focus on the upper side of the straight line AB at point E, which angles we have, the sum of the angles must be equal to 180 degrees. So we have this angle that is 45 degrees, plus the missing angle. The missing angle must be equal to 135 degrees in size in order to complete the sum of the angles on the upper side of AB at point E to 180 degrees. So this angle must be equal to 125 degrees. Okay, so then we focused on the pink triangle AD. On the pink triangle AD, the sum of the angles in any triangle is 180 degrees, and especially in the pink triangle AED. So which angles we have? We have here angle x over 2 plus this angle y over 2 plus 135 degrees. In total, they must be equal to 180 degrees. Okay. Okay. So we subtract 135 degrees from this equation, and we get that 180 minus 135 180 degrees minus 135 degrees is 45 degrees, so we got that x over 2 plus y over 2 is 45 degrees. We multiplied this equation by 2, and we found out that x plus y equals to 90 degrees. We subtracted x from this equation, and we found out that y equals to 90 degrees minus x. Okay, then we implemented the Pythagoras theorem on triangle BOD. It again, we implemented the Pythagoras theorem on the yellow triangle, triangle BOD. According to the Pythagoras theorem, in the yellow triangle, triangle BOD, cosine x equals to r squared plus r squared minus 2 squared over 2 times r times r. Repeat again, on the yellow triangle, triangle BOD, cosine x equals to r squared plus r squared minus 2 squared over 2 times r. So cosine x equals to r squared plus r squared is 2r squared, 2 squared is 4. So it is 2r squared minus 4 over 2r times r is 2r squared. So here 2r squared over 2r squared is 1 and 4 over 2 is 2. So here we will have minus 2 over r squared. So according to equation number 1, we found out that cosine x equals to 1 minus 2 over r squared. Then we focus on the green triangle, triangle ACO. On the green triangle, triangle ACO, according to the Pythagoras theorem, cosine y equals to r squared plus r squared minus 2 squared over 2 times r times r. Repeat again. In the green triangle, triangle ACO, cosine y equals to r squared plus r squared, that is 2r squared. And here we have also minus square root of 2 squared is 2 over r squared over 2r squared. So here 2r squared over 2r squared is 1, and here we have 2r squared over 2r squared is 1, and here we have 2 over 2r squared is 1 over r squared. So in conclusion, we found out that according to equation number 2, cosine y equals to 1 over minus r squared, and we have already found out that y equals to 90 degrees minus x. Therefore we substitute y in this equation, equation number 2, by 90 minus x, and we will get that cosine y equals to cosine 90 degrees minus x. According to this equation, that y equals to 90 degrees minus x. So we substitute y by 90 degrees minus x, and we have that trigonometric identity that cosine 90 degrees minus x equals to sinus x. Okay, so in conclusion, we found out cosine y equals to sinus x. Therefore, we can substitute cosine y by sinus x in this equation, and we get that sinus x equals to 1 over minus 1 over r squared. This is the equation according to equation number 2, and we already found out that according to this equation, equation number 1, cosine x equals to 1 minus 2 over r squared. Okay, so here we defined 1 over r squared as t. So in the equation number 1, we have cosine x equals to 1 minus 2, and 1 over r squared is t, so we substitute 1 over r squared by t, and we found out that cosine x equals to 1 over minus t, 1 over minus 2t. And we already found out that according to equation number 1, sinus x equals to 1 here sinus x equals to 1 minus 1 over r squared. 1 over r squared is t, so we substitute 1 over r squared by t, and we found out that sinus x equals to 1 minus t. Okay, so we have a question for cosine x and a question for sinus x. Then we use the trigonometric identity that sinus squared theta plus cosine squared theta equals to 1. And we implement it here on sinus x and cosine x. So sinus x equals to 1 over t. Therefore, sinus squared x will be equal to 1 minus t squared. And cosine x equals to 1 minus 2t. So cosine squared x equals to 1 minus 2 squared. 1 minus 2 minus 1 minus 2t squared. Okay, so here sinus squared x is 1 minus t squared plus cosine squared x is 1 minus 2t squared, and it must be equal to 1 according to the trigonometric identity. We open the brackets on this side of equation number 1. We found out that according to equation number 1, 1 minus t squared equals to 1 plus t squared minus 2t. And we open the brackets here also. 1 minus 2t squared equals to 1 plus 2t squared minus 2 times 2t is minus 4t. And that is equal to 1. So here we have 4t squared plus t squared is 5t squared minus 2t minus 4t is minus 6t, and then we have 1 on both sides of the equation, so 1 will get cancelled and we left only with 1 here. So we found out that 5t squared minus 6t plus 1 equals to 0. 6t is 5t minus t. Okay, so we substitute 6t by 5t minus t, and we got that 5t squared minus 5t minus t plus 1 equals to 0. Then we took 5t as a common factor. We took out 5t as a common factor from those two expressions, and inside the brackets we left only with t minus 1. Then we took minus 1 as a common factor from those two expressions, so inside the brackets we left only with t minus 1, that is equal to 0. Then we took t minus 1 as a common factor out from these two expressions, so inside the brackets we left only with 5t minus 1, that is equal to 0. Okay, so here we have two solutions to this equation, either t minus 1 equals to 0 or 5t minus 1 equals to 0. Okay. So, repeat again, either t minus 1 equals to 0 or 5t minus 1 equals to 0. T minus 1 equals to 0, so t equals to 1. And according to our definition, t equals to 1 over r squared. Therefore, 1 over r squared equals to t, that is 1, or 1 over r squared is 1. We multiplied this equation by r squared, and we found out that r squared equals to 1. Then we took out a root from this equation, r squared equals to 1, so the square root of r squared is r, is equal to the square root of 1 is 1, or minus 1. Minus 1 is not possible because r is the length, so we left only with r equals to 1. Okay, we have the other possibility that 5t minus 1 equals to 0. If 5t minus 1 equals to 0, then 5t equals to 1. Then we divide this equation by 5 and we get that t equals to 5. So t is 1 over r squared. That is equal to 5. Because multiply this equation and found out that r squared equals to 5. We took out a root from this equation and found out that r equals to either 1 square root of 5 or plus square root of 5. 1 square root of 5 is not possible because r is a length, so we left only if r equals to square root of 5. Okay, and then here we have BD, called BD is not the diameter of this circle. Why? Because it doesn't pass for the center of the circle, that is to say it doesn't pass for point O, that is the center of the circle. Therefore, it must be shorter than the diameter. Because why? Because the diameter is the longest chord in the circle. Okay, so DB must be shorter than the diameter, that is 2R. DB must be shorter than the diameter, that is 2R. And B here, DB equals to 2 units. DB equals to 2 units. And we substitute dB by 2, so 2R is greater than 2. We divided this inequality by 2 and we found out that R must be greater than 1 unit. So the possibility that R equals to 1 is not correct because it is less than, it's because R must be greater than 1 and the R equals to 1 is not possible. So we left only with the possibility that R equals to square root of 5 units. And square root of 5 units is 2.236 units. So the answer to the question is that R, the radius of this circle, equals to square root of 5 units, that is 2 times 236 units. Okay, thank you very much.